For introduction, heat stress is one of the major safety issues faced by workers, especially those working in construction sites and other outdoor environments. High temperatures can lead to dehydration, heat exhaustion, heat stroke, and reduced productivity if workers are exposed for long periods. Currently, many workplaces still rely on manual methods to monitor weather conditions. These methods are often slow, inaccurate, and unable to provide immediate warnings when the environment becomes dangerous. Because of this, our project aims to develop an IoT-based monitoring system that automatically collects environmental data, calculates the heat stress level using the WBGT index, and provides real-time safety alerts through an online dashboard. This allows supervisors to make faster and more informed decisions to protect workers' health and safety.
Heatwave have significant impact on human health, especially for people who outdoors such as construction workers, farmers, and road maintenance workers. One of main effects is heat-related illness. When workers are exposed to high temperature for a long period, they will increase the risk of heat exhaustion and even heat stroke. Another common problem is surf dehydration and heat cramp. During hot weather, the body loses a lot of water and mineral through sweating. In addition, extreme heat causes a fatigue and reduce productivity. Workers easily become tired and more quickly lose concentration. This health risk how why continuous heat stress monitor is important. Our project objective to track ambient temperature, globe temperature, and humidity in real time via online API. Second, to provide a visual dashboard with status, normal, caution, danger for supervisor. The third is automatically calculate the simplified WBGT index to determine heat safety level. These are the main tools used to develop our heat stress monitor system. First, Open Meteor API provides real-time weather data including ambient temperature and relative humidity. Next, Google Colab runs our Python program which relative the weather data, calculate the WBGT index, determine the heat stress level, and send to the result to the cloud. Finally, this board receives the data and display it on a real-time dashboard with live reading, graph, and safety alert, making it easy for user to monitor heat stress condition.
Okay, now moving on to the next slide, WGBT index. First, let's understand what is WGBT. WGBT stands for wet bulb globe temperature. WGBT is specialized measure of environmental heat as it affects both humans and animals. This is highly important because unlike a simple temperature measurement that you might see on a standard thermometer, WGBT is much more comprehensive. It simultaneously accounts for air, temperature, humidity, heat radiation, and air movement. Okay, now let's look at how this index is calculated. At bottom left side of the slide, we can see that 70% of the humidity is primary driver of heat strain, and then only 2% of the WGBT index is from radiant heat, which is our sun, our sun radiation. Okay, and then only 10% is from ambient, which is basic air temperature. This value is taken from the wikipedia.com. Okay, so moving on to the right side of the slide, we can see the WGBT category. It has 5 category. The first one is when WGBT is lower than 25.6 until 27.7, it is still in white flag color. And then category number 2, when the WGBT index is 27.8 until 29.4, it is green color. And then for number 3 category, when the WGBT index is 29.5 until 31 degrees Celsius, it has become yellow flag color. And then moving on to the fourth category, when it is 31 until 32, it has become more dangerous, and then it turns into red flag color. And then the most dangerous one is 32.2, which is black in flag color. Okay, so for the next slide is our safety threshold that we set in our program. Okay, the system maps WGBT values into four distinct safety categories for user decision. The first one is normal, safe to do outdoor activities. The second one is caution, active rest in shade. The third one is high danger, high heat stress. And then the fourth one is extreme danger. Stop outdoor activity if possible. Okay, for the safe limit, it is below than 28. This is often morning time or night time. Okay. So for the caution limit, it is 28 until 30 degrees Celsius. And then for the danger limit, which is peak hour in the afternoon, which is 30 until 32 degrees Celsius. And then if it is more than 32.2 degrees Celsius, it has become extremely danger limit. So the system will detect, and then it will detect extreme danger and suggest to stop outdoor activities immediately.
So, as for the project, we're using the Thingsboard. So this is the Thingsboard dashboard. So as you can see, it appears three different status, which is the first one is immediate status. It show the prominent text banner at the top, which act as a safety alert to tell environmental condition instantly, such as reading safety alert level equal to normal, which is in the safe conditions. And then we have the trend monitor, which explain that the line graph is a live chart to monitor the changes of weather over time, plotting the ambient temperature, globe temperature, and WBGT index together. And the last one, we have the current reading, which is the point out of the digital gauge at the bottom left, which provides a direct WBGT index measure for a quick visual check. Next, for the coding, we were using Google Colab. So this explain the brain of our system running in the background. So I will explain it a little bit. Which is the first one? We have data ingestion, which explain that the script is configured with coordinates for Shah Alam, Selangor, Malaysia to fetch live data from the Open Meteor API. And the next one is the core algorithm of the coding, which is to point out the function that calculates a simplified industrial wet bulb globe temperature, which is WBGT, based on the live data. And then I will explain about the risk assessment, which is we highlight the get alert level function, which maps calculation onto explicit safety risk category, and it will walk them through the logic. WGT under 28 Celsius is normal safe condition, up to 30 Celsius is caution, which is increased risk, and up to 32.2 Celsius is in danger, which is high heat stress, and anything above the trigger will uh, be on the extreme danger, which is stop outdoor activity. And the last one, I will explain about the continuous operation, which is we have draw the attention to the terminal output at the bottom, which prove the system runs a non-stop live online with the system that successfully sends data packet.
To conclude, our project successfully achieved its objectives by developing a real-time heat stress monitoring system using IoT technology. The system automatically retrieves weather data, calculates the simplified WBGT index, and displays the results on a ThinkSpot dashboard. This enables users to monitor environmental conditions continuously and receive immediate safety alerts whenever the heat stress level change. Compared to traditional manual monitoring, our system provides a faster, more efficient, and data-driven approach to workplace safety. In the future, this project can be further improved by integrating real IoT sensors, GPS tracking, mobile notifications, and predictive analytics to provide even more accurate monitoring and early warning capabilities. Overall, we believe this system has strong potential to improve worker safety, reduce the risk of health-related illness, and support safer outdoor working environments. Formation and development of this project were supported by several reliable sources. First, we use the Open Meteo Weather API to obtain real-time environmental data such as temperature and humidity. Second, we use ThinkSpot documentations as the main reference for developing our IoT dashboard and telemetry system. We also referred to the Occupational Safety and Health Administration (OSHA) guidelines on heat stress management and workplace safety. Lastly, we consult the National Institute for Occupational Safety and Health or NIOSH for information regarding occupational exposure to heat and recommended safety practices. This reference help ensure that our project follows accepted standards and provides accurate heat stress monitoring. That concludes our presentation on the IoT heat stress monitoring system.